So as you know that today we are going to start this BGP. BGP is border gateway protocol, right? And of course it comes under path vector routing protocols, right? Path vector routing protocols. This is the only protocol which comes under EGP as well, exterior gateway protocol. So we do not have any other option under EGP rather than BGP, right? So this is the only protocol which you can use as EGP over here, right? Now the question is that how it is different from IGPs, from other routing protocols, as well as you must have this information that where can we implement BGP, because of course, as you know very well from CCNP itself, that BGP is a border gateway protocol which will always be used to connect to different ASs with each other, right? Because if you are having two devices into two different ASs, then you do not have any other option, any other routing protocol to configure between them apart from BGP. Because if you are talking about EIGRP, then definitely like if you are having two routers and if both of them are in different ASs, then you cannot form neighborship with using EIGRP. Because for EIGRP it is mandatory to match their AS number to form EIGRP neighborship, as well as like K values and some other things were also present over there to form neighborship, right? But here in BGP, because in BGP, even if you are having two different routers into two different ASs, then also you can form BGP neighborship, right? That is why we are calling it as exterior gateway protocol, because the main purpose of having exterior gateway protocol is just to form neighborship, just to perform routing in between two different ASs as well, right? So this was the reason so that they launched this BGP, because it is not always necessary to use same ASs on both routers which are connected to each other. Like for an example, if you have connected your customer router to the service provider router, then it is never possible, or it is not mandatory for them to, or you can say it is not possible for them to use the same AS number, right? In same manner, like for an example, if you are talking about OSPF, it is also not mandatory, and also it is not possible to use the same area IDs on both routers, right? So if in case if you are having different area IDs onto two different routers, then will it be possible for OSPF to form neighborship? Because in OSPF as well, if you are having two routers, then it is mandatory that both of them must be in same area. If they are not in same area, then definitely they will not form OSPF neighborship. I hope that you people are getting my point here. Have you understood it or not? So of course we were having some issues previously, like in OSPF it was mandatory to match their area IDs, and in EIGRP it was mandatory to match their ASs. But in BGP we do not have that type of requirement to form BGP neighborship, right? Even if you are having two routers into two different ASs, then also BGP can form neighborship, right? That is why we are calling it as EGP, exterior gateway protocol, which can be used to interconnect to different ASs. And I hope that all of you are aware with the definition of AS, autonomous system. Are you?
Yes.
Are you? All of you are. All of you must be aware with the definition of AS, autonomous system. Like autonomous system is a group of devices, network devices under a single administration, under a common administration, right? So of course, one organization represents one AS. So if you are going to interconnect two different organizations together, then of course you have only one option, which is BGP. There are some other differences also exist in between IGPs and BGPs as well. Like for an example, if we talk about IGPs, they were developed to handle up to 1,000 of routes inside their routing table. If you are having more than 1,000 of routes available in your network, then definitely you cannot use any IGP such as RIP, ICRP or OSPF. So if you are having more than 1,000 of routes or more than 1,000 of prefixes, then of course you have only one option available, which is BGP. Only one protocol is available, which is BGP. So however, like when they developed this BGP, they put this convergence process in a side. They throw it away, that okay, we will see this convergence later on, but they were focusing only on scalability, that protocol must be highly scalable. What do you mean by highly scalable? Like for an example, IGPs were able to handle up to 1,000 of routes, 1,000 of prefixes inside their routing table. But here in BGP, of course, you can have lakhs of routes available inside its BGP table as well as routing table. But make sure that it's not I mean, it's not up to your BGP only. It will be also depending on your hardware capabilities as well. Yeah, of course, it is true that BGP can handle up to lakhs of routes. But what if your hardware do not support or do not have enough memory available? So what will happen in that case? Of course, if you are talking about lakhs of routes available, lakhs of prefixes available in the routing table of routers, then you must have enough memory available on your hardware device, I mean on your hardware as well, right? So it will also be depending on your hardware device as well, whether BGP can have lakhs of routes available inside its own routing table or not. Fine. So it's not all about BGP, I mean it's not all about routing protocols only. It will also depend on your hardware capabilities as well, right? So that's why what we say actually, that if you are going to implement BGP, it's not, I mean like if you are thinking to implement BGP, make sure that you are having enough hardware capabilities, hardware configuration. Because if your devices do not have minimum requirement or minimum required hardware capabilities for BGP, then definitely you cannot implement BGP. You cannot run BGP on those devices, on those network devices. Like for an example, I hope that all of you have seen a problem on routers after enabling network address translation. Sometimes what happens that if you enable NAT on your devices, then I mean it's iOS becomes crashed, and I mean exactly, that's not a message actually, that's kind of like information that you got that okay, now your iOS has crashed, memory dumped out or something like that, right? So it will happen due to lack of memory. So like for an example, we are having that you must have the, I mean you must fulfill the minimum requirement of memory before going to configure netting. Because if you are going to configure netting, then definitely you must know that there will be a net table, translation table, in which table it will maintain connection table. You understand? Like if you have configured net, then it starts to maintain a connection table. Fine. And to keep that connection table, it will require to have memory. So if your device do not have enough memory available, then definitely it will not be possible for you guys to enable net on your hardware devices, right? That is why this NAT cannot be enabled on 3550 series of switch. However, it is layer 3 switch. Even you cannot enable this NAT on 3750 series of switches as well. However, 3750 series of switch is also layer 3 switch, but still you cannot enable NAT onto that. Even though if you are talking about 2600 or 3700 series of routers, and if you are not having good memory available, very good memory available, like if you are having only 128 MB, then of course NAT will not work. To enable NAT, you must have at least 256 MB of memory. If you have your memory less than 256 MB, then definitely it will not be possible for you guys to enable NAT onto your device. And if you still enable NAT onto your device, then it will start to give you some error messages that NAT was not enabled successfully or something like that, or memory dump or whatever it is, right? But thing is that it will not be possible for you guys to enable NAT if you are not having minimum required memory available on your device, on your hardware, right? So in same manner, like if you are thinking to enable BGP, if you are thinking to implement BGP onto your, I mean inside your network, then make sure that your devices, your hardware devices are having enough available memory. Because of course, like I don't remember exactly that what are the minimum requirement to enable BGP. However, it is not possible to enable BGP itself onto 3550 series of switches or 3750 series of switches. You know why? Due to hardware resources only. Because if you talk about the BGP, of course it will consume more and more hardware capacity, I mean you can say capabilities. So problem is that you do not have enough hardware memory, or you can say you do not have enough hardware resources available on 3750 series of switches as well as 3550 series of switches. That is why it is not possible for you guys to enable BGP onto these series of switches, right? So if you want to enable BGP onto your switch as well, then you have to buy either 4500 series of switch or 6500 series of switch. Fine. So onto those series of switches, you can easily enable this BGP protocol. I hope that you people have understood my point. However, on most of the routers, you can enable this BGP. like whether you are using 2600 series of routers or 2800 series of routers or 3700 series of routers, 7200. Of course 7200 comes under like service provider routers, right? 7600 series of routers also comes. You will in most of the cases you will find this series of routers at the end of service providers only, like 7600, 12,000, 10,000 series of routers, right? Even nowadays we have started, not nowadays actually, from last from a long time we have started to use ASR series of routers now. ASR series of routers at the end of service providers, right? So in most of the cases you will find only and only ASR series of routers at the end of service provider. And in ASR also we are having some models like ASR 1000. Yeah, of course 9000 is also there. ASR 1000, ASR I think 5000 is also there. Then ASR 9000 is also there. So in ASR itself you are having, we are having multiple series of routers, fine. But remember that ASR series means, if you are talking about ASR series means you are talking about routers only. Under ASR series you do not have any switch, you are having only and only routers under ASR series. So it will be good for you guys to have some knowledge about ASR devices as well, ASR routers as well, and you can find ASR routers onto Cisco website itself, right? So you can easily search information related to ASR series of routers, right? Very easily, fine. So I was telling you that okay, BGP is when they developed this BGP, they put this convergence time in a side, and they were focusing only on highly scalability, higher scalability, right? So actually BGP is highly scalable. And what is the meaning by highly scalable? That it can have lakhs of prefixes available inside its BGP table. Have you understood it or not? It can have lakhs of prefixes available inside its BGP table, right? Its routing table or its BGP table will never get crashed, if you inject a lot of prefixes in it. However, if you are talking about IGPs like such as OSPF or EICRP, they have maximum limitation, right? They have maximum limitation for their database table as well as routing table. In most of the cases we usually says that IGPs cannot handle more than 1000 of prefixes, 1000 of routes inside their routing table as well as database table. Like in EICRP you are having topology table. What does it mean? That inside the topology table of EICRP you cannot have, you should not have more than 1000 of prefixes. And if you are having more than 1000 of prefixes inside the topology table of EICRP as well as database table of OSPF, might be that their routing table will be crashed. And once the routing table of device of your layer 3 device will be crashed, then definitely you know very well that what can happen. Your devices will not be able to switch your data, because now your routing table has crashed. Means that now you do not have any entry available inside the routing table of your devices. I hope that you people have understood my point. Hello, tell me if you are having any issue, please let me know, right? So problem with IGPs was that they cannot handle more, they cannot handle more than 1000 prefixes available inside the routing table as well as database table. But in BGP there is no limitation. The only thing which is which makes, or you can say that which must be fulfilled, is hardware capability. If you are having enough hardware capabilities or hardware resources available onto your device, then definitely you can have lakhs of prefixes available inside the BGP table as well as in its routing table. That is why onto 6500 series of route switches as well as 4500 series of switches, you are having your RAM, your memory up to like 4 GB, 2 GB, 6 GB, 8 GB. You understand? So what is the use of having RAM onto your network device up to like 8 GB? However, still we are not having 8 GB RAM available into latest laptops as well. Like usually we are getting RAM up to 4 GB only. However, onto those switches also, onto those switches you can have RAM up to 8 GB. So you can think that why would we having RAM up to, memory up to 8 GB available onto your devices? Of course only for BGP, because if you talk about 6500 series of switches and 4500 series of switches, usually you will configure them on at the end of service provider only. And if you are going to configure them at the end of service providers, it means that you have to configure BGP. And if you are talking about BGP at the end of service provider, then BGP table will be having like lakhs of routes. And if it is having lakhs of prefixes available inside its BGP table, then definitely it will require to have more and more memory. as well. That is why we are having memory, I mean RAM available onto this series of switches up to 8 GB. So I hope that you people have understood that it is not really easy to implement BGP everywhere. And I would like to tell you one more thing. See, it is never recommended to configure BGP if it is not required. It is never recommended to configure BGP if it is not required. You know why? Because if you are going to configure BGP, if you are going to implement BGP into your network, then of course it will require, or it will consume, or you can say that of course you must have very good hardware configuration. Apart from hardware configuration, you must have very good network engineer as well, who is having very good knowledge, in-depth knowledge of BGP as well. And if you are going to hire that network engineer who is having in-depth knowledge of BGP, then definitely it will cost you more, is not it? So it is never recommended, or you can say that it is not always required to implement BGP everywhere, right? So there are certain cases, there are certain situations in which you can think about BGP, you can implement BGP into your network, right? So I will be discussing all those conditions, all those situations in which of course you should implement BGP. But remember that it is not always good to implement BGP everywhere in all types of networks, right? So first of all, you have to analyze whether BGP is seriously required here to configure or not, right? If BGP is not required, and if you can work without BGP as well, then you will never ever prefer to implement BGP in your network. I hope that you people have understood my point here, right? So that is why it is not always obvious to have BGP in all networks, right? Like for an example, if you are talking about a small network, then definitely you will never find BGP configured into that network. So I'll let you know that, okay, in which situations of course you will prefer to implement BGP, right? So now one more thing, as I said that, okay, it is highly scalable, right? Highly scalable than IGPs, because it can have a huge number of prefixes available. It can handle huge number of prefixes available inside its BGP table as well as a routing table. I hope that you people are getting my point, right? The second point is here, of course it is highly scalable. Apart from scalability, it is reliable too. It is reliable too. You know why? Because BGP is the only routing protocol which uses TCP port number 179. So you must understand that BGP will always be configured, will always run over TCP port number 179. Fine. That is why I am saying you that it is highly reliable as well. It is also highly reliable protocol, because all types of packets, all types of messages of BGP will always travel over TCP. And first of all, I mean, even before going to configure BGP peering, BGP neighborship, it has to form TCP connection, because BGP will always work over TCP, and TCP is a reliable protocol. That is why we always say that BGP is the only protocol which is fully reliable routing protocol. Apart from BGP, no one is fully reliable routing protocol. Like we are also having IGRP, OSPF as well as RIP. So no one out of them is fully reliable routing protocol. You know why? Like for an example, if you take an example, EIGRP or OSPF, hello packets will be generated by both of them periodically. Like EIGRP will be responsible to generate hello packets in every 5 seconds periodically, whereas OSPF will also be responsible to generate hello packets in every 10 seconds or 30 seconds periodically, right? But none of them will use TCP. Is there any procedure in EIGRP or in OSPF to get an acknowledgement in response of a hello packet? Was there any acknowledgement? Tell me. Exactly. Like in EIGRP, only for some types of messages we were having this acknowledgement, and of course, like in OSPF as well, we were having that acknowledgement only for some specific types of messages only, not for all of them, right? That is why we always say that BGP is the fully reliable routing protocol, and also it is more secure than other routing protocols, because everything will travel over TCP connection only. That is why we can also call it that, okay, it is a secure protocol rather than IGPs, right? So BGP is a secure protocol as compared to IGP. So I hope that you people have understood all these points. So if still you are having any problem, please let me know. Visual, understood all these things? Fine. Now the thing is, I have discussed so many things related to BGP and ICPs. Of course, like I said, that ICPs will always be configured within an AS, whereas if you are going to configure routing in between two different ASs, in between two different organizations, then you will always prefer to configure BGP only, because if you are going to interconnect to different organizations, it means it is possible to have more than 1,000 of prefixes available inside the routing table. And if you are having more than 1,000 of prefixes available inside the router's routing table, then definitely you must prefer to configure only and only BGP. Fine. So that is why we always says that if you are going to implement, if you are going to interconnect to different organizations with each other, if you are going to connect to different ASs with each other, then definitely you have to use only and only BGP. So are you okay with it? Fine. Now let's talk about types of customer as well. Let's talk about types of customer as well in BGP. So if you talk about the types of customers, like we are having here various types of customer available, right? You can have single homed customer, is not it? Then dual homed customer, then single multi-homed customer, then so we are having these types of customers available, right? Your customer can be single homed customer can be dual homed customer, your customer can be single multi-homed customer as well. As apart from that, you can also have dual multi-homed customer as well. So now let's discuss the differences in between these types of customers. So if you are talking about single homed customer in BGP, it means you are having, not in BGP, it's not in terms of BGP, it is in terms of customers only, right? So if you are talking about single homed customer, it means that you will be having only one ISP and your customer will be having only and only one connection coming from one ISP. Only one connection will be there. So will you ever configure BGP here in terms of like if you are having single homed customer? Will you ever prefer to configure BGP here? Of course, no, never. If you are having a single home customer, you will never think for BGP, even though you are connected with internet, right? But still, what will you do here? You will configure a static default route in the direction of ISP, and then you can configure further netting, network address translation. That's fine. That will be great for you. That will be enough for you actually, because you do not have any redundant connection over here, right? So why would you configure BGP? So if you do not have, like for an example, you can configure BGP. Let me discuss it first of all, these types of customers, and then after I will teach you some other things as well. So this time, this type of customer is always known as single homed customer, right? Now let's talk about multi-homed customer. In this also, you will be having only one ISP, only one customer router, but this time at least two connections from the same ISP. In case of dual homed customer, if your customer is dual homed customer, then your customer will be having at least two internet connections from the same ISP. At least two internet connections from same ISP. It could also have three internet connection as well, but still you will call it dual homed customer. So if you are defining dual homed customer, then it must have at least two internet connection coming from same ISP, right? So in this case, of course, if you configure default route in the direction of ISP onto both links, then as you know that for default routing it cannot perform load balancing. So of course, in this case, if you want to utilize both links, then you have to use BGP here. So in case of if you are having dual homed customer, then of course you can think about BGP, you can go for BGP. So are you getting my point or not? Tell me.
Yes, sir.
See guys, try to understand that if you are having dual homed customer, if you are having two, if you are having redundant internet connection, then of course you can think for BGP. You can think to configure BGP in your network, right? So this type of customer is known as dual homed customer. Now let's talk about single multi-homed. In case of single multi-homed, you must have at least two ISPs. Let's say this is ISP1 and this is what? ISP2. In case of single multi-homed customer, you must have at least two internet service providers, and then customer must have at least one connection from each ISP. At least one connection from each ISP. See, you must have at least two internet connections, and from each ISP you will be having only one internet connection, right? Only one connection. So this type of customer actually will be known as single multi-homed customer, right? Single multi-homed customer. So this type of customer will be known as single multi-homed customer. And again, because towards ISP it is always recommended to configure a default static default route in the direction of ISP, but still now if you configure a static default route in the direction of ISPs, then you know very well that what type of problem can occur over here, because for default routing it cannot perform load balancing. So finally you have to implement here BGP, right? So if you are having single multi-homed customer, then you have to implement only and only BGP, because if you configure default route in the direction of ISPs, then definitely you are not going to get load balancing, and to achieve load balancing again it will be required to configure BGP. So if you are having single multi-homed customer, then also you have to implement BGP only. Then you can also have dual multi-homed customer. So in dual multi-homed customer also you must have at least two ISPs available, and now customer will also have at least two routers, like customer one. This same customer will be having at least two routers. Two customer edge routers will be there. This is C customer edge 1, and this is what? Let's say this is customer edge 2. Fine. So this type of customer will be known as dual multi-homed.
And those customers must be supposed BGP.
Of course. On both of them you will configure BGP now, and you can easily get load balancing. I will teach you all these things.
What about same series routers or different?
No, it's not mandatory. Like here you can use 4500 series of switch. Here you can use 6500 series of switch. It doesn't make sense. It doesn't create any problem. Even though you can have router on one end, you can have router on another end, you can have switches over. Clear? So this type of customer will be known as dual multi-homed customer. Remove this single, make it dual. Dual multi-homed customer. Fine. Good. So only these types of customer internet users we can have. However, it is always recommended to use either single multi-homed or dual multi-homed. If you are having two internet connections, make sure that you are getting them. You are having those internet connections coming from different service providers. You understand what I mean to say? Fine, guys. Okay, let's come back to BGP once again. If we talk about the BGP, in BGP, of course, we will be using ASs. And now we are having two types of ASs available in BGP. One is 2 bytes long AS. Second, 4 bytes long AS. Are you getting my point or not? So 2 bytes long AS as well as 4 bytes long AS. If you talk about the 2 bytes long ASs, it means you are having 16 bits. You understand? And if you are having 16 bits, means that its range will be from 0 to. Now first and last cannot be used. From 1 to 6, 4, 5, 1, 1, it is known as public. I mean, this range is known as public AS. Remaining will be private ASs. Means that from, tell me, 6, 4, 5, 1, sorry, yes, 1, 2, 2, 6, 5, 5, 3, 4. All these ASs will be known as private ASs.
Registered.
Not this is private. Anyone can use them. Public means register. Public AS is same as public IP. Private AS is same as private IP address. Anyone can use private AS, whereas to use public AS, you have to ask to your ISP to provide you public AS. And it is not very easy to get the public AS. It's not very easy to get public AS. If you wanna get public AS, then you have to apply it to your service provider. Then they will check whether you are really eligible or whether it is really required for you, that okay, you should have public AS or not. If they don't think so, that okay, it is required, it is mandatory for you to have public AS, then they will never provide you. Never ever. Like to have a public AS, at least like either you must have very good or very large internet network. Actually, you must have an enterprise network, right? Second, if you are service provider, then definitely you must have a public AS. But if you are a normal end user, is normal customer, then definitely it is not mandatory for you to have public AS. Nowadays they have also started to use 4 bytes long ASs. In it, these ASs are not going to be finished very soon, because 32 bits long ASs are available. It means range can be from 0 to 4.2 billions. Now these 4 bytes long ASs can be represented into two format, either like 16 bits dot 16 bits, dot 16 bits. Means that 1265535.1265535 in this manner, or you can directly represent it in decimal number in between 0 to 4.2 billions. So it will be depending on you that how do you want to represent them. Are you getting my point or not? Have you understood it or not? See, you can represent your 4 bytes long ASs with using two different methods. For first, 16.16 bits, total number of bits will become again 32. Second, directly 32 bits. You can take any number in between 0 to 4.2 billions. Understood or not? For sure. Good. Fine. Now let's talk about types of packets, or you can say types of messages in BGP, right? So you are having here multiple types of packets, or you can say messages in BGP. First, second, third, fourth, notification. Only these four types of packets, these four types of messages are available in BGP: open and keep alive, update, and finally notification. Fine. But remember, each type of BGP packet, each message of BGP will travel over TCP connection only. It is not possible to transmit any single, try to remember, it is not possible to transmit any single message of BGP, any single packet of BGP without forming TCP connection. Remember, all types of packets of BGP, all types of messages of BGP will always travel over TCP. So if TCP connection was not came up successfully into established state, till that BGP will not send any single packet, any single message. So to form BGP neighborship, or you say to transmit any packet of BGP, it is mandatory that first of all TCP connection must come up, and then after BGP can transmit any type of packet, or you can say any type of message. Now here in BGP, because we are having only four types of messages like open, keep alive, update, and notification, we have to understand that what is the uses of open, what is the uses of keep alive, what is the uses of update, and of course this notification as well. Let's start it from open message itself. So if you talk about the open and keep alive, actually these two messages are same as hello messages in EIGRP and OSPF. Like in EIGRP and OSPF, we were having hello packets. And what was the role of hello packets in EIGRP and OSPF? To discover a neighbor and also to maintain neighborship. Because hellos were also used as a keep alive messages as well. Here, the work done by hello packets for EIGRP and OSPF will be performed by open and keep alive messages in BGP. Whatever the work performed by hello packets for EIGRP and OSPF, the same task, same work will be performed by open and keep alive messages, keep alive packets in BGP. So actually open and keep alive combinedly they are same as hello packet for IGPs, like for EIGRP as well as OSPF. See, I will start from open packet itself. So if I talk about the open packet, this open message will be transmitted by BGP only once when neighborship comes up. Once neighborship will come up, then after BGP will never transmit any open message. Fine. Remember that open message will be transmitted by BGP only once when neighborship comes up. When Once neighborship have came up, then after BGP will never transmit any open packet. So in short, I will say that open message will be used by BGP to exchange initial configuration between two BGP peers, which is required to form BGP peering, which is required to form BGP neighborship. Try to understand. Open packet of BGP will be used by BGP to exchange only that information which is required to form neighborship. Such as, if you talk about the contents of open packet, like it contains its version. Remember, version must be same on both sides. BGP version. Nowadays we are using BGP version 4. Earlier on we were using BGP version 3, and before that we were using BGP version 2. But nowadays in all iOS versions we are using only and only BGP version 4. So by default in latest iOS's it's not gonna to be possible to mismatch their version, right? But by using command you can modify your version. By using command you can modify your version. So remember that BGP version must be same, and this version information will be contained by open packet, open message. Second is what? Router ID. If R1 is generating its open message, right, so it will define its own version, its own router ID into it, and then after router ID it will also define its own AS. Like for an example, on R1 I'm running AS 100, so in open message it will also specify that AS. It will also specify that AS, but it's on AS, right? Then next is going to be, next will be tell me.
Hold down time.
Hold down timer. And remember, I mean, these four components are the part of open packet. Hold down timer will be negotiated by both of them, right? So I hope that you people have understood that which type of components will be contained by open message. Version, router ID, on AS, hold down timer. Router ID does not does not create any difference. If even router ID is common, then also they can form neighborship. Of course it's on AS. Sometimes what happens, let's say that this is R1 and this is what? R2. Let's say, because in BGP there is no concept of dynamic neighborship. Is there? Is there any concept of dynamic neighborship? And also there is one another limitation. There is also one another rule in BGP. Like you cannot run more than one AS. You cannot configure more than one AS on a single router. You cannot configure more than one AS. You cannot run more than one process of BGP on a single router. If you have configured router BGP 100, only 100 will be running onto your device now. If you want to configure multiple processes of BGP on a single router, then it is not possible, because at same time you can configure only one process, one AS of BGP on a single router. So and one more thing, that if you remember from CCNP, that in BGP it is always required to configure static neighbor.
Yes.
It is always mandatory to configure neighbor statically. And if you are configuring your neighbor statically, will it require to have any multicast address? Because it will transmit unicast packets. It will send unicast packet, unicast messages for BGP, right? Like open, keep alive, all of them will be unicast packets. So that is why here in BGP we do not have any multicast address available. Have you heard any time, have you heard before that okay, we are having any multicast address available for BGP? Like we were having multicast addresses available for EICRP as well as OSPF. Like for EICRP we were having .9, .10, for OSPF we were having .5 and .6, for version 2 we were having .9. But here for BGP we do not have any multicast address available. You know why? Because in BGP it will always transmit only and only unicast messages, unicast packets. Fine. So here in BGP it will always require to configure your neighbor statically, right? So open message will always be unicasted. Not only open message, all types of messages of BGP will always be unicasted. Now in BGP it is also required, it is also mandatory to configure your neighbor statically, right? And when you configure your neighbor statically, I hope that you remember it from CCNP itself that you are also required to define your remote AS as well. Right? Neighbor is this and remote AS is this. Means that you always specify along with neighbor command about your remote AS as well. Along with neighbor command, you also specify your remote AS. I mean, like for an example on R1, if you are saying that okay, neighbor is R2, but you have to, along with that, you have to define its neighbor, sorry, its remote AS as well. I mean, the AS which is configured on R2, right? So now let's say that on R1, I have configured that remote AS is 200. I mean, let's say that I have configured on R1 that okay, R2 is running AS 200. Now, whenever R2 will send its own open message to R1, it will specify its own AS. At that moment, R1 will compare that AS which came into open packet as well as that AS which you configured in neighbor command. If both of them are getting mismatched, then of course it will start to show you that your peer is in wrong AS. Your peer is in wrong AS. I hope that you people are getting my point. Is not it? So all these things are there. That is why it is also mandatory to have your AS information, to carry your information within open message of BGP. And we are also saying that version must match of BGP, right? So how will it be possible for devices, for two peers, for two neighbors to define or to compare their versions with each other? That is why this open packet will also be responsible to carry this information. I mean, carry this version information as well, right? Apart from that, it is also having like router ID. Of course, in near future, I will let you know that okay, router ID will also play a vital role in BGP for path selection. That is why it is also mandatory to exchange their router ID information as well with each other, right? So that is why whenever they will send open packet to each other, open messages to each other, then they will also exchange. I mean, they will also specify their router IDs within open messages, right? Finally, hold down timer is also there. Of course, hold down timer is there, and it is by default as 4 minutes. That this hold down timer is not that hold down timer which is by default configured in BGP, which is by default 180 seconds. See, the default hold down timer for BGP is 180 seconds, right? So I will let you know later on. But here, this hold down timer inside the open message will always be 4 minutes. Or what can we do to confirm it? I will capture your open packet and then I will show you that okay, this is the hold down timer. I hope that you people have understood it, right? The second thing, of course, okay, now I have discussed everything related to open packets. See, open packets are also having some other things too, some other components too, right? So right now I'm not going to specify all of them because so many things are there. Like some capabilities are also there. Like for an example, if your router R1 is capable for doing something, then it has to inform to R2 as well that I'm having these capabilities. In same manner, R2 has to inform to R1 as well that okay, I'm also having these all capabilities, right? So those capabilities information will also be contained by open message, open packet. Have you understood it or not? So I will let you know later on that what are the meanings of capabilities, right? How many types of capabilities we have in BGP and how can we enable disable these capabilities and all these things, right? Apart from it, okay, let's go for keep alive message. I hope that you people have understood the uses of open message. So remember that open message will be used by BGP just to exchange that information which is required to form BGP neighborship, BGP peering, right? And then after, like for an example, if they have exchanged their open packets, open messages successfully with each other, then after they will start to send keep alive messages to each other. And remember that BGP will generate keep alive periodically in every 60 seconds. However, open messages will be generated by BGP only once when neighborship comes up, right? Then after it will never send next open message, next open packet towards its neighbor. But keep alive will be generated by BGP periodically in every 60 seconds, right? Just to inform to its neighbor that I'm still alive. That is why here its packet name is what? Keep alive. So basically in IGPs, the uses of hello packet was just to exchange that information which is required to form neighborship and also to maintain neighborship, because as a keep alive also you were using those hello packets. But here in BGP you are having separate types of packets for doing the same task which was performed by hello messages during IGPs, right? So here BGP will be responsible to generate your keep alive messages periodically in every 60 seconds. Have you understood it or not? And remember that BGP will generate keep alive message if it has received open packet from its neighbor and also it has negotiated that okay, now everything is fine and now I want to form neighborship. Then only it will send, it will generate keep alive message. Otherwise, it will not generate any keep alive message. And one more thing, by default, your hold down timer in BGP is 180 seconds. What does it mean? That if you do not receive a keep alive packet, keep alive message from your neighbor till 180 seconds, in that case, remember that it will break down. It will break down. It will tear down BGP peering. Remember that in BGP, hold down timer is what? 180 seconds. It means that if you do not receive any keep alive message, keep alive packet from your neighbor for 180 seconds, then definitely it will tear down, it will break down neighborship after 180 seconds. That is why we says that it converges slowly. If there is any change, it will come to know about that after 180 seconds. But same as we configured BFD, bidirectional forwarding detection, in OSPF as well as in EICRP. The same thing we can also configure in BGP as well. We can configure BFD in BGP as well, so that in case if BFD detects any kind of failure, then it can directly indicate to BGP, so that BGP can break its neighborship. So it is also possible to configure BFD along with BGP, right? But as I said that, okay, when they developed this BGP, they put this convergence in a side, but they wanted to have higher scalability, right? So BGP is highly scalable, but of course, yeah, it converges slowly, right? It converges slowly. I will let you know that why does it converge slowly. Just wait for a moment. But I hope that you people have understood the uses of open as well as keep alive message. Next message is what? Update packet. So update is same as like you are having updates during EICRP and all those routing protocols like OSPF and all, right? So update packet will be responsible to carry your routes information in it, right? Update packet will be responsible to carry your routes information. So basically update has two main components. One is known as path attributes. Second is known as, tell me. First one is path attribute and second one is known as an LRI. These two main components are available in update packet. However, you can also have some discarded route as well. I mean, there is one another thing as well, discarded route, something like, I will let you know later on that what is that component of update packet itself, right? But in most of the cases you will find that these two things, path attributes and NLRI, will be main components of update packet. Have you understood it or not? So updates are having these two main things, path attributes and LRI. And LRI is what? Network layer reachability information. Means that here we are talking about prefixes. Here we are talking about prefixes, path attributes. So if we talk about path attributes, then it's all about, like, I hope that you people have already gone through them during CCNP as well. Like you were having AS path attribute, AS path, med, local preference, all that kind of information will be contained by path attributes. Path attributes are those criteria of BGP which are used by BGP for best path selection. See, the most important difference, or you can say the another difference in between IGPs and BGP is that in IGPs we were having only and only metric to define to manipulate their best path selection. But in BGP you are having so many criteria to manipulate their path selection, which are known as path attributes. So in BGP you are having multiple things, multiple metric types, you can say, which can be used to manipulate its best path selection. Hello, which are known as, I mean, in language of BGP, they will be known as path attributes. So I hope that you people have understood the meaning by path attributes as well. So remember, path attributes are those criteria of BGP which are used by BGP to perform its or to define its best path selection. Have you understood it now? For sure. Piyush, path attributes are those criteria of BGP which are used by BGP itself to perform its best path selection. NLRI is prefix, and here the most important thing is, see, BGP saves bandwidth, network bandwidth, while it is sending an update messages to its neighbor. Of course, it saves some bandwidth. You know how? Like in ACRP and OSPF, like in OSPF and EICRP, with in both of them, what was happening? Let's take an example of EICRP. Let's say this is prefix. For each an individual prefix, they were having all those criterias, like what is the bandwidth, minimum bandwidth, cumulative delay, load, reliability, MTU, everything was attached with each and every individual prefix. Is not it? Those things in EICRP like bandwidth, load, delay, reliability, MTU, hop count, these things were attached with each and individual prefix. But in BGP it's not gonna to be happen like that. What happens here, let's say that there are 20 prefixes, and for all those 20 prefixes, if you are having same attributes, what will it do? It will create, first of all, path attributes in which it will specify all those attributes, right, which are coming, which were for all these 20 prefixes, right? And then it will create an NLRI, network layer reachability information. Under NLRI, it will specify those 20 prefixes without attributes. So there will be a common field for path attributes for all those prefixes which were having same attributes. But remember, if you are having different attributes for different prefixes, in that case BGP will also require to send your update into multiple update packets, into multiple update messages, if you are having different attributes for different prefixes. So remember that like if you are having different prefixes with different attributes, then definitely BGP will require to create multiple update messages. But in case if BGP is having same attributes for all prefixes, then it will create only one update packet in which it will specify path attribute, put those attributes, and then it will specify only NLRI. Under NLRI, you will never get any path attribute, remember. Under NLRI, you will never get any path attribute. Under NLRI, network layer reachability information, you will get only and only prefixes information. So I hope that you people have understood the uses of update packet as well, right? So now after update packet, remember update will also be unicasted packet, right? The second is going to be notification, and notification is very simple over here, that if your BGP is going to break neighborship due to any reason, then before breaking up its neighborship, before tearing down its neighborship, it has to send a notification message to its neighbor that I'm going to break neighborship due to this reason. It will send a notification message towards its neighbor just to inform that I'm going to tear down, I'm going to break this neighborship due to this reason. So for that purpose here we are having this notification. As per its name itself, you can try to understand this notification. Notification means is going to be used to notify someone. It's going to be used to notify someone. So if you want to notify your neighbor before tearing down your neighborship, then of course you will send a notification message to your neighbor that I'm going to break this neighborship due to this reason. Only for that purpose here in BGP we are having this notification message. So these four types of packets, or you can say these four types of messages, are available in BGP. But remember, notification will be generated by device in that case only when it is going to break neighborship. That's it. Fine. So all these types of packets were available in BGP. Done. Let's start it once again. So now I'm going to make you understand the FSM, finite state mechanism of BGP. Finite state mechanism of BGP. In short, you can also call it BGP neighborship states. BGP neighborship states. In technical language, we call it finite state mechanism in BGP, right? Or you can say finite state mechanism of BGP, right? So we have to discuss this finite state mechanism now in BGP. So you can also call it BGP neighborship state. So you know very well that if you talk about the BGP neighborship states, they will, I mean, it will always start from ideal, then it will move into connect, then after connect it will become active, then after active it will become open, sent, then open, confirm, and finally it will be established. Ideal, connect, active, open sent, open confirm, established. So we have to understand the meaning by all these BCP neighborship states, or you can say we have to go through the finite state mechanism now. Finite state mechanism, just let me know. BGP message types, as I said that it is having only 4 types of messages. Open, keep alive, update, notification. Open message, after TCP session is established, both neighbors send open messages. Each neighbor uses this message to identify itself and so specify to specify its BGP operational parameters. The open message includes the following information like version 234. Currently we are using only version 4. This negotiation continues until both neighbors agree on the same version. I mean, neighbor must have same version. You can change your neighbor by using command neighbor version. Autonomous system number, hold down timer, BGP identifier, and optional parameters, right? So these 4 contents are there, right? See, this is maximum number of seconds that can elapse before the router must receive either a keep alive or an update message. You understand? So all these things are there, and the hold time must be either 0 second, in which case keep alive must not be sent, or at least 3 seconds. The default Cisco hold down time is 180 seconds. If the neighbor hold down timer differ, the smaller of 2 times becomes the accepted. That's it. So they will negotiate their hold down timer if they are having different hold down timer. So this information would be contained by open packet, right? Then BGP identifier, which is router ID, right? BGP identifier which means that they are talking about router ID. So all these things are the all these components are the part of open message. Then after keep alive is there. If your router accepts the parameters specified in its neighbor's open message, it responds with a keep alive. Subsequent keep alive are sent in every 60 seconds in Cisco by default, or a period equal to 1/3 the agreed upon hold down timer. So if hold down timer is negotiated as 210 seconds, so by default keep alive will become 70 seconds. Update message, however, you can modify it manually by using commands, right? So update message, as I said, that it will be having an LRI path attributes. Apart from that, it is also having withdrawn routes. So let's say that you have one of the interface, one of the link has gone down. So how will it inform to its neighbor? Again, it has to send update message, right? It has to send an update packet towards its neighbor, but it will specify that prefix under withdrawn route, so that neighbor can withdraw those prefixes from its BGP table. So I hope that you have understood the uses of withdrawn routes as well. Notification message. The notification message is sent whenever an error is detected and always causes the BGP connection to close. That's what I said to you. I told you that if due to any error BGP neighborship is going to be teared down, then before tearing down your neighborship, it has to inform its neighbor that okay, I'm going to tear down this neighborship due to this error, due to this reason. Like an example of use of notification message is the negotiation of BGP version between neighbors. If After establishing a TCP connection, a BGP3 speaker receives an open message specifying BGP version 4. The router responds with a notification message stating that the version is not supported. The connection is closed and neighbor attempts to reestablish a connection with BGP version 3. Now this is finite state mechanism. BGP finite state mechanism, or you can say BGP neighborship states. So as I said that you are having ideal, connect, active, open send, open confirm, and finally established. This is called finite state mechanism, and this mechanism will tell you that neighborship in BGP can move from which state to which state due to what reason. So here you are having like ideal, connect, active, open send, open confirm, established. Back to ideal. These arrows shows you that okay, from which state, neighborship BGP peering can move from which state to which state due to what reason. Let's say it has moved from ideal to connect state. Input event 1, and what is the meaning by input event 1? BGP has start. So if you have start your BGP, then it will directly move from ideal to connect state, right? If input event 1 occurs, so your neighborship will move from ideal to connect state. Means if your BGP has started, see, BGP start. Input event 1 means BGP start. Input event 2 means BGP stop. Input event 3 means BGP transport connection open, means TCP connection has opened. Input event 4 means BGP transport connection closed, means TCP connection has closed. It's not like it was not open, it was open but it has closed now. Input event 5 means BGP transport connection open was failed, TCP connection didn't came up successfully. 6, input event 6 means BGP transport fatal error. 7, connect retry timer expired, which is by default 60 seconds in BGP. Remember, connect retry interval is by default 60 seconds in BGP. Then 8, hold down timer expired. Input event 9, keep alive timer expired. 10, receive open message. 11, receive keep alive message. 12, receive update message. 13, receive notification message. Now as per these input events, we will try to understand this in this finite state mechanism. See, if your BGP has started, input event 1 has occurred, your neighborship will move from ideal to connect state. Ideal to connect only. See, from ideal your neighborship first of all will move into connect state. From ideal it cannot directly move to active or open send or open confirm, right? So first of all it will move into connect state. Now in connect state anything can happen. Input event 3 can occur, input event 5 can also occur, input event 2, 4, 6, 8 to 13 can occur. So if input event 3 occurs, the meaning by input event 3 is what? Open, BGP transport connection is open, means that if during connect state your TCP connection has opened, then it will directly move into open send state. If input event 5 occurs, the meaning by input event 5 is that TCP connection was not opened. See, 5, BGP transport connection was, connection open failed. So if your TCP connection was not formed successfully, then your neighborship will move from connect state to active state. Now if input event 3 occurs, input event 3 means what? That in case if your TCP connection has opened successfully, try to understand the meaning by input event 3 is what? TCP connection has opened successfully. So if input, if your BGP, if your TCP connection has opened successfully, then again from active it will move back, it will move into open send state, but it can also come back from active state back to connect state as well. Like whenever your neighborship will move into active state, your BGP will always start its connect retry timer. See, remember, whenever your neighborship will move into active state, your router will set its connect retry timer. If your connect retry timer get expire, then it will directly move back into connect state, and in connect state again it will start, it will initiate to form TCP connection. It will initiate, it will try to form TCP connection. Try to understand that if input event, see, we are in active state, right? We are in active state, and why BGP neighborship, BGP peering will move into active state? If connection was not open, TCP connection, transport connection was failed. If TCP connection was not open successfully, then it will move from connect to active, but it will remain in active state till its connect retry timer gets get expire. So once its correct retry timer will expire, you will see that your neighborship will move back from active to connect state. But by default, connect retry timer is what? 60 seconds. So in active state, of course, your router, your BCP has to do wait for next 60 seconds, and after expiration of 60 seconds, your your neighborship, your BCP peering will move back from active state to connect state. Have you understood it or not? Even you can check it here, input event 7, connect retry timer expired. But in case if input event 3 has occurred, let's say that TCP connection was open during active state, it will move into open sent. In open sent state, see, if input event 10 occurs, the meaning by input event 10 means it has, see, open message. If input event 10 occurs, then it will move from open sent into open confirm. See, after receiving open message only, it will remain in open sent state till it receives an open packet from its neighbor. It does not mean that after sending open packet, after transmitting open packet, it will move into open confirm. No, it has to receive open packet during open sent state only. Then after only it can move into open confirm. But along with this input event 10, input event 4 can also occur. If someone have closed your TCP connection, input event 4, you can check it out. If TCP connection has closed, then your neighborship can move back from open sent state to active state. And also, if input event 2 occurs, the meaning by input event 2 is what? BGP stop. BGP stop. Let's say you have stopped BGP. In that case also, your neighborship will directly move from open sent back to ideal state. Remember, from open sent state, you cannot directly move back into connect state. You can move back into active state or in ideal state. Or you can also move from open sent to open confirm. So just after receiving open message from neighbor, it will move from open sent to open confirm. If input event 2 occurs now in open confirm, then it will also go directly, it will also move back directly into ideal state. Either 2 to 8 actual, if any input event in between 2 to 8 and then 10, 12, 13 occurs, then it will move back from open confirm to ideal state, right? But in case if input event 11 occurs, if input event 11 occurs, which means that you have received keep alive message. So during open confirm state, if you receive a keep alive message from your neighbor, then you will move into established state. Remember that during open confirm state, if you receive any tell me keep alive message, then it will move into established state. In established state, if anything happen, if any input event occurs in between 2 to 8 or input event 10 or input event 12 or input event 13, if any one of the input event occurs, remember your neighborship, your BGP peering will go back from established state into ideal state. So I hope that you people have understood the meaning by finite state mechanism. Now the question is that in which conditions your neighborship can stuck in ideal state. Like for an example, if you have administratively shut down your neighbor, then your neighborship, your BGP peering will stuck in ideal state. In which conditions, in which situations your BGP peering can stuck in active state? So remember that if your authentication is failed, if your authentication was failed, then also your neighborship, your BGP peering can stuck in active state, right? Apart from it, there are some other reasons too by which your neighborship can stuck in active state. So I'll be discussing all of them with you later on, but right now just try to understand that if your authentication is not was not successfully done, then also your neighborship will stuck in active state. Even your neighborship can also stuck in active state in that situation as well, where you have enabled BGP only on one end, but you haven't enabled BGP on another end. Then also your neighborship will stuck in active. So try to read all these things as well. It's not that I'm only who is saying on all these things. You see, ideal state. BGP always begins in ideal state in which it refuses all incoming connections, but when a start event 1 occurs, the BGP process initializes all BGP resources, starts the connect retry timer, and initiates the TCP connection to the neighbor, and also it will move into connect state. Listens for a TCP initialization from the neighbor and changes its state to connect. Connect retry timer is what?
60 seconds.
The connect retry time for each subsequent attempt is twice the previous time, meaning that consecutive wait times increase exponentially. Means that if by default connect retry timer is what 60 seconds, next time it will become 180, next time it will become 240 seconds. You understand? Okay, 180 means it will become then 360. 60, 120, 240, and in that manner, right? Connect state. In this state, BGP process is waiting for the TCP connection to be completed. If TCP connection is successful, then connect retry timer will be clear and it will move into open sent state. If TCP connection was not formed successfully, then it will move into active state. You see, if the TCP connection is unsuccessful, the BGP process continues to listen for the connection to be initiated by the neighbor, reset the connect retry timer, and transition to active state. If the connect retry timer expires while in connect state, the timer is reset. Another attempt is made to establish TCP connection. Right? Active state. In this state, the BGP process is trying to initiate a TCP connection with the neighbor. If the TCP connection is successful, the BGP process clears the connect retry timer, complete initialization, sends an open message to the neighbor, and transitions to open send. The hold down timer is set to 4 minutes over here. In open sent state, your hold down timer will be set to 4 minutes. This is for this situation only. It does not mean that BGP hold down timer is 4 minutes, because BGP hold down timer is by default 3 minutes, 180 seconds. If the connect retry timer expire while BGP is in active state, the process transition back to the connect state. As I told you that in active state, if your connect retry timer get expire, then it will move back into connect state. So that's what they are trying to make you understand.
So what is the difference between that hold down time and this hold down time?
This time, I mean, this is not like this hold down timer is going within the open packet. No, it means that a BGP process clears the connect retry timer, completes initialization, and sends an open message to the neighbor and transition to open send. And in open send, it will set its hold down timer for 4 minutes. Let's say that your neighborship has moved.
4 minutes.
If your neighborship has moved into open sent state, then it can keep itself in open sent state itself for next 4 minutes. If it is not getting any response from its neighbor. But once it will receive an open message from its neighbor, it will transition into open confirm state. That's the meaning by this hold down timer. Open sent state. In this state, open message has been sent and BGP is waiting to hear an open from its neighbor. Once it will hear the open from its neighbor, then it will move into open confirm. In this state, BGP process waits for a keep alive in open confirm, right? Once it will receive this keep alive, it will move into established state. So I hope that you people have understood this finite state mechanism in BGP. Fine.
So can you suppose?
Yes. What happened? Okay, you wanted to draw this finite state mechanism.
Finished drawing it? Okay, you want? Yeah, this one.
This one.
Finished.
Guys, have you understood all those things which I discussed with you related to BGP till now? Great. So BGP is the only protocol which is completely reliable protocol, because all types of messages of BGP will be transported over TCP. Done? Good. As I discussed earlier on with you, that in BGP you can have, or like, let me tell you some basics of BGP now with you. I mean, I will discuss some basic things. It supports authentication. It's not it, but only one type of authentication, which is MD5. The second thing, here there are two terminologies available in BGP. One is IBGP, another one is what? EBGP. So what do you mean by IBGP and EBGP now? Internal border and external border gateway protocol, right? So actually this is, I mean, we are not having two different protocols actually in BGP, like IBGP and EBGP are two different protocols. No, it's not like that. It's not true. It does not mean that you are having two protocol inside BGP itself. No, actually these are terminologies. These are terminologies. Like for an example, if you are having two neighbors are in same AS 100 and AS 100. For R1 now, R2 will be known as IBGP neighbor, internal border gateway protocol. I mean IBGP neighbor. If your neighbor is in same AS in BGP, then it will be known as IBGP neighbor. And if your neighbor is in different AS, then it will be known as EBGP neighbor. Right? Fine. If you receive anything, any prefix from your IBGP neighbor, it will be known as internal route. If you receive your route from an IBGP neighbor, then it will be known as internal route. Are you getting my point or not? So if you are receiving any route from an IBGP neighbor, then it will be, I mean, all of them will be known as internal routes. And if you are receiving anything from EBGP neighbor, if you are receiving anything from an EBGP neighbor, I mean, if you are receiving route coming from EBGP neighbor, then it will be known as external route. So here there is no rule like we were having during ICPs, like redistributed routes will be known as external, and all of them, all other routes which are coming from the same area or different area, or from in ESRP from same AS, they were called as internal route. In BGP it is different. Here it does not mean that okay, if your route is redistributed, then only you will call it external. No, there is only one concept, which is if you are receiving route coming from EBGP neighbor, will be known as external route. If you are receiving a route, a prefix from an IBGP neighbor, then it will be known as internal prefix. It is also possible, let's say this is R1, this is R2, and this is R3. Let's say R1 is using AS10, R2 is using 20, and R3 is also using 20. So here these two neighbors will be known as IBGP neighbor, and these two neighbors will be known as EBGP neighbor. Let's say that R1 has advertised anything 10.1.1.0/24, it will give it to R2. For R2 it will become external route. But when R2 will give it to R3, for R3 it will be known as now internal. Does not matter whether it was originated from different AS or something like that, right? It would be completely depending on your neighbor only, from where you received this prefix. If you are receiving your prefix coming from EBGP neighbor, it will be known as external prefix. If you are receiving it from your IBGP neighbor, then it will be known as internal prefix only. In this way only you can specify whether your route is internal or external. Have you understood it now or not? Now there is one another difference also exists in case of BGP. Like if your route is internal, I mean if you are receiving any route from your IBGP neighbor, then by default its AD value will be 200, and if you are receiving any route coming from your EBGP neighbor, then for it is your default AD value will be 20 in BGP. Fine. Now question is that why do we have AD value, its AD value as 200 for IBGP, and why do we have its AD value as 20 for EBGP, right? See, try to remember the things. Like if we are talking about IBGP routes, IBGP neighbor, it means IBGP neighbor will always be in common AS. IBGP neighbor will always be in same AS. Now, you must remember that BGP's convergence is so slow. Convergence is slow in BGP. It converts slowly as compared to IGPs. Fine. If you're talking about IBGP, it means that your neighbors will be in same AS. Let's say this is R1, this is R2, you understand? And this is, let's say this is R3. All of them are interconnected with each other now. Fine. Great. If all of them are in same AS, what is the necessity of configuring BGP? You can also configure IGPs too in place of BGP. Or you can do one thing, you can configure BGP as well as IGPs. So which should be preferred? BGP or IGPs? IGPs. Because within an AS you can also configure, IBGP, it means all of them are in same AS 100. So remember that you will always prefer to implement IGPs within an AS. So IGPs must be preferred over BGP. That is why they have configured their AD value for IBGP as 200, which is higher than any other IGP. So if you have configured BGP here in this network, in this AS, as well as you have configured either RIP, EICRP or OSPF, so it will start to prefer EICRP or OSPF or RIP over BGP, because BGP converge slowly. And here, because you are talking about a same AS, common AS, it means it is not necessary for you to configure BGP as well. But let's say that if you have configured BGP, then of course it will prefer by default IGPs, because IGPs converge. Of course they converge quickly. IGPs converge quickly as compared to BGP. That is why for all IGPs we are having their default AD value lower than IBGP. So I hope that you people have understood now that why do we have AD value 200 for IBGP. So like here within an AS, if you have implemented BGP as well as IGP, so by default they will prefer IGPs. That is why for IBGP we are having its AD value as 200 by default, right? Fine. For EBGP it's 20. EBGP means neighbor will be in different AS. Let's say this is R1 and this is what? R2. This is in AS 10 and this is in AS, let's say 20. And this is what? AS 20. This is AS 10, this is AS 20. So it will be known as now EBGP. Fine. Means if you are talking about two different ASs, it means you are talking about two different organizations as well. And if you are going, if you are going to perform routing in between two different organizations, it means the total number of prefixes can be higher. Of course, total number of prefixes can reach more than, can reach 1,000 of prefixes, right? So if you are having more than 1,000 of prefixes, will you ever prefer to configure IGP? But in case by mistake, if you have configured any IGP in between these two different ASs, by mistake if you have configured IGP, like for an example OSPF or EICRP, will it ever preferred, will your routers ever preferred those routes which are learned through IGPs over EBGP? No, because by default for EBGP its default, its AD value is what? 20, which is lowest among all routing protocols. AD value 20 for external prefixes is lowest among all routing protocols, among all IGPs. You can take an example of EICRP, which is having the lowest one, which is 90. So if by mistake you configure any IGP in between these two routers R1 and R2, you see it will still keep on to preferred BGP only. It will install routes coming through BGP only inside their routing table. That is why by default for eBGP they are having their default AD value as 20. So these are the reasons, so that for iBGP we are having their default value as 200, and for eBGP we are having their default value as 20. So of course, if you are going to configure routing in between two different organizations, then you must prefer BGP. But if you are going to configure routing within a single organization, then you should prefer IGPs. That is why these two different values are available in BGP. Have you understood it or not? Great. Apart from it, I mean, till now we discussed about the AD values and all these things, fine. You must remember that in BGP we can define neighborship between two directly connected neighbors as well as indirectly connected neighbors as well. This is another feature of BGP. Previously in any one of the IGP it was not possible, or you can say it is not available. You understand what I mean to say? Remember, in BGP you can configure your neighborship between directly connected device as well as indirectly connected device. Fine. Like for an example, if you are having this kind of topology R1, R2 and R3, of course in between R1 and R2 you can configure BGP peering, but apart from it you can also configure BGP peering in between R1 and R3 as well, due to static neighbor configuration only. Because in BGP you have to configure your neighbors statically, so that they will always send unicast packets, and unicast packets can move from one device to another. I mean, like, that is why in BGP it is possible to form neighborship in between two indirectly connected neighbors as well. There are some rules also existing, right? There are some rules also exist here in BGP for iBGP, for eBGP, which are different from each other, right? But right now we are not going to discuss any rule related to that, but after some time I'll be going for that, right? I mean, after some time I'll be discussing all those things with all of you, but right now it's not necessary. Fine. After discussing all these things, like they can form neighborship with directly connected devices, with indirectly connected devices. I mean, all these things are there. Fine. Apart from it, now we have to discuss about BGP path attributes as well. BGP path attributes, and this is the most important topic of BGP, and most of the questions related to BGP will be asked from BGP path attributes only. If someone is taking your interview, during interview you will see that most of the questions will be asked from BGP path attributes only. So BGP path attributes are those criteria which are used by BGP to define its best path. BGP path attributes are those criteria which are used by BGP to define its best path. Now, BGP path attributes are divided into two main categories. One is known as well-known. Another one is known as optional. Under well-known also we are having two different categories further: mandatory and discretionary. Under optional, again we are having two more categories: transitive and non-transitive attributes. So remember, BGP path attributes are those criteria which are used by BGP for its best path selection. So you have to understand each and everything over here, right? And what is the meaning by well-known mandatory? What is the meaning by well-known discretionary? What is the meaning by optional transitive? What is the meaning by optional non-transitive? And then we have to know that which attributes comes under well-known mandatory, which attributes comes under well-known discretionary, which attributes comes under optional transitive, which attributes comes under optional non-transitive. So I hope that you people have understood. I mean, at least you have came to know that, okay, in this way BGP path attributes are divided into multiple classes, is not it? So the meaning by well known is like everybody knows about them. That's the meaning by well known, right? Optional is like it's not I mean by default BGP is not gonna to make is not gonna to take these attributes is not gonna to make these attributes part of its BGP updates. I mean by default BGP will not carry forward optional BGP attributes, right? If you configure BGP to carry optional attributes, then only BGP will be responsible to carry your attributes, I mean optional attributes, you understand? But in case of well-known mandatory, like if you talk about the well-known mandatory now, because under well-known also you are having two different classes, one is mandatory, another one is what? Discretionary. So meaning by mandatory is what? That BGP has to, or BGP will always carry forward all that information, whether update is going towards IBGP neighbor or EBGP neighbor, it does not, I mean, matter. But it will always keep all those attributes. All those attributes will come under well-known mandatory. Means they will always go along with your BGP updates, whether you are giving your updates to your IBGP neighbor or EBGP neighbor. Well-known discretionary. They are well-known but discretionary. Means sometimes BGP will take them within BGP updates. Sometimes BGP will not take them within BGP updates. It will be depending on your type of neighbor, whether your neighbor is IBGP neighbor or EBGP neighbor. So sometimes what happens that some of the attribute information will be carried within BGP updates for IBGP neighbors only, not for EBGP neighbor, right? So we have to discuss all of them, that which type of attributes comes under well-known, discretionary, then of course optional, transitive and non-transitive. But I will discuss all these things in next class now, that what is the meaning by, I mean how which attributes comes under mandatory, which attributes comes under well-known discretionary, which attributes comes under optional transitive, and which attributes comes under optional non-transitive. So if you are having any question, please let me know so that we can discuss it here. Otherwise we can continue this BGP in next class, and tomorrow your class will be at sharp 9:30. Tomorrow I'm not having meeting, don't worry about that, right?